I am Divya Somakumar, and in today's video, we are going to learn about stacking. Now, what exactly is stacking? Stacking is an ensemble learning technique which combines the predictions from multiple machine learning models on the same dataset. Stacking works on the similar lines of cross validation. As a result, it deals with overfitting nicely. Now, let's build a model for stacking. First and foremost, we will import our necessary libraries. Import numpy as np, import pandas as pd. Now let's run this. Now we will import our dataset. For this, I have taken the dataset on gender classification from the Kaggle website. I will provide the link for the same in the description below. Let's import our dataset. df is equals to pd dot read underscore csv. Now let's run this. Let's look at the head of our dataset. df dot head. So we have long hair, we have forehead width, we have forehead height, nose wide, nose long, lips thin, distance underscore nose to lip long, and then gender, male or female. So these are our columns. Now let's look at the info. df.info. So we have 5,000 rows and we have around 8 columns. These are the columns. Now we have to divide our data into x and y. Before dividing, if you observe, gender is an object column. And we know that if we want to apply our models, our data should be integers or floating variable. So we'll have to first convert this gender, that is male and female, into numerical column. How do we do that? We do that by label encoding. So first we'll divide into x and y. X is equals to df dot iloc. I need all the rows. I need all the columns except the last column. Dot values, and y is equals to df dot iloc. I need all the rows. I need only the last column. Dot values. Now, if you look at y, how does y look? Y looks like this: male, female, and data type is object. Now, let's convert this Y into a numerical data. How do we do that? From sklearn dot preprocessing, import label encoder. We'll create an object for label encoder. Le is equals to label encoder. Now we will fit this label encoder on our y. Le dot fit underscore transform. We want to transform our y. Since we do not have a parameter called in place equals true, we will reassign this into our y. We have successfully converted all our categorical variables into numerical variables. Now, if you check for y, you have ones and zeros, where 1 represents man and 0 male and 0 represents female. Now, let's divide our data set into X train and Y train and X test and Y test. So basically, we are dividing our data set into training data set and testing data set. How do we do that? From sklearn dot model underscore selection, import train underscore test underscore split. xtrain, xtest, ytrain, ytest is equals to train underscore test underscore split x comma y comma test size test underscore size equals zero point 0.2 random underscore state equals 1. Now we will import two models, that is logistic regression model and decision tree classifier. Since here we are dealing with classification, that is we want to determine whether a particular person is a male or a female. So let's import logistic regression from sklearn dot model import logistic regression from sklearn dot tree import decision tree classifier. Now let's start with our stacking. For stacking, we'll have to first install MLExtend because stacking is not available with sklearn library. We have to download it externally. So how do we download? Pip install ML extend. Now we have downloaded ML extend. Now we can use this library to import our stacking classifier. So how do we do stacking? From ML extend dot classifier import stacking classifier. Now let's create an object for logistic regression. Logreg equals logistic regression. DT is decision tree classifier. Here we will keep default parameters dt1 equals decision tree classifier. Here we'll keep the criterion as entropy. Criterion equals entropy. So we are going to fit the following models. Now we create a MetaLR or meta classifier, which is a logistic regression. Meta underscore LR equals logistic regression. Logistic regression. So our meta LR is ready over here. This is a required parameter in stacking. You need a meta model, which is logistic regression. Now let's create an object for stacking. Let's call it stack. Stack is equals to stacking classifier classifiers. Oh, we have to first make a list of all our models. So first we'll create the list of all our models. Over here we'll create a list. Let's call it model underscore list equals logreg dt dt1. Let's run this. So our model underscore list is ready. So this is the list of machine learning models which will be combined to find one particular solution in stacking. Now let's write or let's make the object for stacking classifier. Let's call it stack is equals to stacking classifier. Over here, we have to specify our classifiers, which are the models that we are going to put it in. That is models underscore list. So you have logrec, you have decision tree, and you have decision tree with entropy. And you have to give the meta classifier. Meta underscore classifier. This is a required parameter. If this is not specified, then the model won't work. Meta, meta underscore LR. Now let's fit our model. Stack dot fit x train y train. Now we have to predict ypred is equals to stack dot predict x test. Now we have to get the classification report. How do we do that? From sklearn dot metrics import classification underscore report print classification underscore report by test ypred. Our classification report is now ready. Over here, you can see that the accuracy of this model is 97%. So, 97% of the time, when this model is used, the person is correctly predicted as male or female. I hope the stacking algorithm is clear for one and all. Thank you.